All right, let's bring all of this right triangle information together in this lesson. Now, solving triangles. Simple instruction, however, it means a great deal, to be honest with you. Because solving a triangle means you need to make sure that you can identify 6 measures from the triangle. You should be able to identify 3 angle sizes, and you should be able to identify 3 side lengths when it says to solve a triangle. You're not going to get 6 pieces of information. You're going to be given some, and you have to make sure that if you have solved the triangle, you know all 6 values. What do we have available to us? Pythagoras. We can use Pythagoras. If we know 2 sides, we can find the 3rd side. We can use the 180 rule. Well, if we know 2 angles, we can find the 3rd angle using the 180 rule. We can also use the trig ratios from the last couple lessons. Trig ratios, SOHCAHTOA, very repetitive steps. The key being, to find a side length, we finish with cross multiplying. To find an angle size, we finish by inverse trigging. So this is what's available to us. All of this here is what we have available to us when a question says to solve the triangle. Not every question will be solved the same way. So people might have different processes, but you should be able to compare your answers, and all answers should be the same no matter which way you do it. So, example 1, solve for the unknown angles and sides. Everyone approaches it different. It's totally up to you. What's nice is we have one side, a second side, and we do know that we have a 90-degree angle. So we have 3 pieces of information right now. It might help to label the triangle. Sometimes people will do that. I like to do it just to keep myself organized when I'm doing the work. Well, to start with, I'm going to find side B here. Side AC or side B. So if I want to find side B, I have 2 sides in my right triangle. How can I find the 3rd side? Pythagoras. Now, even though I've labeled it B, note that this is the hypotenuse. So we would then, if we're finding the hypotenuse, 24.6 squared, A squared, plus 15.6 squared, the other non-hypotenuse side squared, will equal the hypotenuse squared. Now, normally the hypotenuse is labeled C in the formula, but it's just your hypotenuse, which is B. So what am I going to do to solve this? 24.6 squared plus 15.6 squared to get a value. Bear with me. I have to punch that into the calculator because I wasn't sure how I was going to solve this today because there are so many choices. But if I go 24.6 squared plus 15.6 squared, I'm going to get a value of 848.52. So this, if I squared and added up, 848.52 equals B squared. Remember, that's B squared. If I just want to get B, we always finish by square rooting. And the square root of 848.52 rounds to 29.1. So I'm going to write that in. We have the hypotenuse as 29.1 centimeters. Now, we might have made a mistake, but I like my answer because that's the longest side of the triangle, which it should be because it's the hypotenuse. So that's a good start. So I now have 3 sides, 1 angle. I need 2 more angles. Well, I'm going to calculate the size of angle A now. Well, the size of angle A, I want to calculate angle A from the last video, actually. That's then our reference angle. We're going to use A as our reference angle so I can label my sides. We have side opposite, across from the reference. We have the hypotenuse, across from the 90, and we have the adjacent, attached to the reference angle, but not the hypotenuse. So I actually technically have in this point now all 3 sides. So like we finished last lesson off, when all 3 sides are known, we can use any one of the three trig ratios. However, my suggestion is you should always try to use the information given in the question. We could use the 29.1, but if we made an error here, let's say we made a silly mistake, well, I'm using the wrong thing to try to find something else. And that's just not smart. So I'm going to use the information given to me as much as I can. And at this point, the fact that I have the adjacent and the opposite, well, adjacent and opposite tells me to use tangent. Tangent of angle A, opposite over adjacent, 15.6 over adjacent 24.6. How do we find an angle? Remember, we always second or inverse tan in this case, 15.6 divided by 24.6. So let's punch that into our calculator. We want second tan, inverse tan of 15.6 over 24.6. So divided by 24.6. Now I forgot to mention it, but you should now be in the habit. Check that you're in degree mode, always. At this point, to the nearest degree, angle A, 32.3, is 32 degrees. So there's what we get for angle A, 32 degrees. So I can now put 32 degrees into angle A. Now angle C. Well, angle C is our last calculation. It's the only piece of information we don't have. Well, I'll be honest with you. Angle C, if I have a 90 and a 32, angle C, we can just use the 180 rule. I know that all three angles is 180, so if I take away the 90 and I take away the 32, I end up with a 58 degree angle. So angle C is 58 degrees. But like I mentioned just a minute ago, the problem with that calculation is I used the 32, which is a calculated value. So if I happen to have made an error with the 32, I'm using the wrong thing to calculate something new, which means my something new will probably be wrong as well. There's nothing wrong with doing this if you're confident. I still like the idea of using the information given in the question. So what I'm going to do at this point is I want to find angle C, so I label. Opposite angle C is side opposite. Hypotenuse doesn't change because the hypotenuse is always across from the 90, and that leaves adjacent. So for angle C, I have a new reference angle and new labeling, but it's still the same process. I don't want to use hypotenuse. I want to use the two sides that I know, opposite, adjacent, so it's a tan calculation again. Tan of angle C, but this time the opposite is 24.6 and the adjacent is 15.6. So same two values, but in different positions because we're finding a different angle. How do I find an angle? Inverse trig the angle of 24.6 divided by 15.6. So back to my calculator, second function tan, but this time it was 24.6 divided by 15.6. And what do we end up with? 57.6, which is a 58 degree. So I like that my proper calculation using known information matched up with the 180 rule. So I feel pretty good now that my 32 is correct because my 58 was correct using the non-calculated values. So that's what it means to solve for an unknown angular side. Nothing new here. It's just a matter of organizing and solving the way you think is best. Number 3, maybe pause the video, give it a try. The only drawback is you might do steps that I didn't do, but that's not bad, it's just different. So pause it, give it a try, and then come back and we'll do it together. All right, so what we are looking at, again, I just want to label so I have some labels that I can use to keep myself organized. First thing, I have two angles, so it's easy to calculate angle Z. Angle Z, because I know 140 and 90, 180 minus 90 minus 41. So angle Z works out to be, what do we get? Sorry, 49 degrees. So angle Z is 49 degrees. Took care of that. Now again, the 49 degrees is calculated. It's not a tough calculation. We can probably be pretty confident, but all my other calculations are going to avoid that and only use the information given. So now I want to find side XY, which is also small z. So I'm going to calculate side Z. Well, if I want to calculate side Z, that means I need a reference angle. I'm going to use the information I know. And if that's my side, I have then hypotenuse, I have opposite, and I have adjacent. Well, we're trying to find Z, so we need adjacent. We have the hypotenuse. Opposite doesn't help us. And again, SOHCAHTOA. Well, if we're going to use hypotenuse and adjacent, we're using cosine. So we have cosine of angle X, which we know is 41 degrees, so actually I can put the 41 right in there. Cosine of 41 is adjacent, the unknown Z, over the hypotenuse, which is 75. How do we find a side length? Cross multiply. Inverse cosine if we're finding an angle, but we cross multiply to find a side length. So this is going to be cosine 41 times 75 divided by 1, which equals Z. So I'm going to go to my calculator, cosine 41 times 75. So we have, now this time I don't want a second function, that's to find an angle. We simply do what it says. Cosine 41, close the bracket, times 75, and divide it by 1 to finish. And what do we get? 56.6. So we get side Z equal to 56.6 for a length. So I can add 56.6 to my diagram. Well, I have three angles, and I now have two sides. So now we need to find the length of side X. Well, length of side X, I want to use known information, so here we go again. Find a side, I'm going to use 41 degrees, my reference angle because I know it. This is the opposite side we're trying to find. Hypotenuse is staying the same. And in this case, because it's the same reference angle, we actually don't change our labeling. But in this case, we want the opposite using hypotenuse. Adjacent doesn't help us now because I don't want to use what I calculated. So in order to solve for X, side X, using, again, opposite and hypotenuse, sine. So we have sine, reference angle X still, but we're trying to find the side opposite over the hypotenuse of 75. Sorry, we know that X is 41. I keep forgetting to punch in what I know. Sine of 41, X over 75. How do we find a side length? Cross multiply. Sine 41 times 75 divided by the extra piece will equal side X. And when you punch all that into your calculator, you get X equal to 49.2, which is smaller than the hypotenuse, so at least we're on the right track. So there's all 6 pieces of information known. We've solved the the triangle. So the next bit that brings all of this process of right triangles together is when we have word problems. You've had some word problems in some of your assignments already. So we're just going to quickly review, do a couple because there's a little bit that you need to know. With word problems, the most important thing is to do a somewhat accurate sketch of the question. All right, and the key is if it's somewhat accurate, what's going to happen is you should end up with a right triangle within the question. You have to have a right triangle because we're doing trigonometry problems with right triangles. But again, what can we use to solve it? Pythagoras, 180 rule, or any of the trig ratios, depending upon what it's asking for. The only other bit that's really important here is the fact that you have two terms. You have the angle of elevation as an expression, and you have the angle of depression as an expression. Well, for a situation like it's sort of sketched in the book, if you're someone standing on a cliff looking down at a body of water, and on the water is a boat, but besides being a boat on the body of water, well, there's a bird up in the sky, and you're standing on the cliff. Well, the key here for what angle of depression and angle of elevation is the fact that if you look straight ahead horizontally, that's a 0-degree angle. If you want to look at the bird, you have to tilt your head up at an angle of elevation. You're elevating the angle at which you're looking. So this is the angle of elevation, that there. If I'm on the cliff and I'm looking straight ahead and I look down or depress my view, I now, instead of looking straight ahead, I now am looking down at a specific angle of depression. So it's just some questions talk angle of elevation and depression. We'll look at a couple examples, but it's really important you understand how they work. So if we just actually go back and on the bottom of that page, read the example that's there and see if you can quickly sketch it. Talks about the fact that from the 14th floor of a building, you look at an angle of elevation of 25 degrees to the top of the building across the street and an angle of depression of 74 degrees to the ground floor of the same building. So what this is saying, there's your street and you have a building and you then have another building. Now we honestly don't know how the buildings compare to each other, but we know you're on the 14th floor. And if you're on the 14th floor and you look straight ahead, you'd be looking 0 degrees. But this 0-degree angle distance across is actually how far apart the buildings are. And that can come into play in some questions. But what it says is from the 14th floor, you look up at an angle of elevation to the top of the building. And it's an angle of elevation of 25 degrees. Here you are, if you look straight at 0 degrees, but you're elevating 25 degrees to see the top. But the other possibility is that from that position, you're also able to depress your view and look down at the bottom of the building. And the angle of depression there is described as 74 degrees. So that's how angle of depression and angle of elevation can be utilized. So let's look at some questions and that'll come up. Example 4 on page 24. A 1,000 meter long bike hill has an angle of elevation of 12 degrees. What's the elevation when you're at the top of the hill? Well, it says that it's a 1,000 meter long bike hill. So if you're at the bottom and there's the hill that you're going to ride your bike up, I don't even want to try to do this, but I'm going to so you can mock me and ridicule me. Oh, let's see, there's that. And there's somebody sitting on the bike and the handlebars, and they're riding up the hill. That's not too bad, but they're riding up a hill that's 1,000 meters long. The hill has an angle of elevation of 12 degrees, which means from the bottom of the hill, it's a 12-degree angle of elevation. And they want to know, when you're at the top of the hill, how high are you? There's your right triangle. Understand in these questions what you're solving for. Sometimes you're solving for an angle, sometimes you're solving for a side length. We see the right triangle here. We're trying to find the side length. So I'm not going to actually go through and do the solving. You should be able to do the solving here, knowing you're finding a side. So there's your reference angle, and you should be able to go from there. Again, answers, if you want to see the steps and check, remember my copy of the booklets, you can see the work. But I just want to save some time on the video. We've done lots of solving. You can do that on your own. Number 5, a tree has a 46-foot shadow. If the sun meets the ground at 28 degrees, what is the height of the tree? Well, what's happening here is we know that we have a tree. I'm going to keep it really simple. We have a tree and there's a shadow. Please understand, students with triangle questions so often say, oh, it's a 46-foot shadow. No, I have never seen a shadow suspended in midair. A shadow does not represent the hypotenuse. A shadow is always on the ground, or on a wall, I guess, but there's the shadow of the tree. The shadow of the tree is 46 feet. Now, shadow questions are popular because your object and the ground make 90 degrees, and there's our right triangle. The shadow, we know, is 46 feet. We want to know what's the height of the tree, so we're trying to calculate that length, and it says the sun meets the ground at 28 degrees. Understand, for shadow questions, the sun is up in the air, and the sun's rays come down, and the sun's rays meet the ground. So when it talks about the sun meeting the ground, that's the bottom degree down here. Shadows on the ground, the sun's rays come down and meet the ground down here at 28 degrees. We want to know how tall the tree is. Well, in this case, trying to find a side length again, and I'll tell you, actually the last answer, just for the last question, even though it's too late, was 207.9 meter high. In this question, the tree is 24 5/10 feet tall. You can do the calculating. We've done a lot of that. You can practice that. I want to practice setting questions up right now. So from there, let's go to page 26, question 8. Here's where we have to start thinking a little bit. So keep your questions simple. Somebody's on a Ferris wheel, and they're up at the top of the Ferris wheel, sitting on the Ferris wheel up at the top, waving hello to their friend. And they're sitting on the car. All right. So Ferris wheel, little bomb. There you go. So from the top of a Ferris wheel, 45 meters high. So yes, it's a round Ferris wheel, but we know that it's 45 meters high. Someone looks down at an angle of depression of 46 degrees, and if you read the question in the book, to see their friends. So there's somebody else down here on the ground. Now this person looked down 46 degrees. Here's where you have to be careful with angle of depression, because students will often put 46 degrees in here, but that's not correct. So 46 degrees, you have to think about what I just talked about in terms of angle of depression. Remember, angle of depression is always based on 0 degrees straight ahead. Here's your 46 degree angle of depression to the person. We want to know how far apart the friends are. Well, our triangle, a lot of people start to draw the triangle here, which is perfect. There's your 90 degrees, but the 46 isn't in here. What we do know is we do know that straight up and straight across, we know that that's 90 degrees. So if I think of this as 90, and I know that this is 46 degrees, well, I know that this angle here is 90 minus 46. So our angle inside the triangle is 44 degrees. We have 44 degrees in there because the angle of depression is outside of the triangle we're creating. But it creates this 90-degree angle, and 90 subtract the angle of depression leaves us with a 44 degrees. Now the last thing that's important with this, if you can remember, is that now I have this triangle that's 44 degrees for why we just explained 90. Well, now if I find the angle down at the bottom, which could be argued to be the angle of elevation, well, if I do the 180 rule, 180 minus the 90 minus the 44, we get 46 degrees down here. So this is really important. It can help simplify things. Angle of depression will equal the angle of elevation. Different ways you can do it. There's nothing wrong with working with this question and saying, okay, I knew that that was 44 for the reasons I described. I know that we're 45 meters up, and I want to figure out how far apart the friends are. That's acceptable. But also, the other possibility for this, we know it's 45 meters up, and we know that the angle of depression is 46. Well, if angle of depression is always the same as angle of elevation, well, there's a triangle I could work with to figure out how far apart the friends are. So, two possible, totally acceptable triangles that can be created in these situations. So that's what you're looking at. Angle of depression, angle of elevation. Be careful because sometimes that angle of depression is not actually part of the triangle that you're working with. And from there you can solve it. Answers are at the bottom of that page. Last example to look at here. We have number 9. From a lookout tower, a fire is observed at an angle of depression of 7 degrees. The fire is 1,276 meters away from the base of the tower. How high is the tower? So there's a couple of these actually in the mountains. Kananaskis has one. You can actually mountain bike to. But you've got a ranger up at the top of the tower with his binoculars, and he sits and he looks for fires that may be developing for different reasons. Well, in this case, it says from a lookout tower, a fire is observed at an angle of depression of 7 degrees. So if the ranger looks straight ahead, it's 0, but the angle of depression is 7 degrees. Well, a lot of students, like we just talked about, know that the tower makes a 90-degree angle. And the angle of depression, two possibilities. Hopefully you're thinking angle of depression equals angle of elevation. There you go. We know the fire is 1,276 meters away. So that's one way to solve this question. 7 degrees, 1,276. We want to know how tall the tower is. The other possibility that we just looked at is we know that these vertical and horizontal looking straight away is 90. So if this is 7 degrees, this has to be 83 degrees because it's a total of 90. So the other possibility is you might want to work with this as a triangle that's 83 degrees here, 1,276 meters, and we're trying to figure out how high the tower is. Different numbers, finding different sides, because in this case, if that's our reference angle, we're finding the opposite. If this is our reference angle, in this case, we'd be finding adjacent. So a little bit different steps in solving, but should give you the same answer. Angle of depression, angle of elevation. Got to think about it. So your assignment is booklet, page 22, number 1. I put A and B. I'm not sure that's what I want you to do. Let me double check. No, I don't want A and B. I want, please, let's make that C and B. So C and B, not A. It should be a C because we just did A. So C and B, solve the triangle, 6 pieces of information, page 25, 1 to 10 in the booklet. Answers are there, single triangle word problems. Have fun with it.